Hello everyone, and welcome to today's session dedicated to the following argument, enabling a complete noise, vibration, and harshness experience with a compact NVH simulator. I'd like to introduce today's presenter, Dave Bogema, Director of NVH Solutions at VI Grade. Today's webinar will explain how our industry-first compact NVH simulator enables users to experience the vibration and sound of virtual NVH prototypes with minimal space requirements, allowing the clear and efficient communication of NVH characteristics to development engineers and other stakeholders. Please note that a recorded version of this webinar will be available and distributed per email to all registered participants. The presentation will start in a couple of minutes to allow as many attendees as possible to connect. Please note that you will be muted during the presentation and that you are welcome to ask your questions using the designated Q&A chat window. Selected questions will be answered by the presenter at the end of the webinar. Please also note that at the end of the webinar, you will be invited to participate in a quick survey dedicated to our webinar initiative. We thank you in advance for your feedback. It will help us improving the quality of our initiatives.
Hello and welcome to the launch of the newest member of the VI Grade family of NVH simulators, the first of its kind, the Compact NVH Simulator. My name is Dave Bogema, and I'm the Director of NVH Solutions at VI Grade, and I'm very excited to be here today talking to you about this. Before we get to the Compact NVH Simulator itself, I'd like to cover a few basics first, and what led us to developing the Compact NVH Simulator. The first few slides here will probably look familiar if you've ever been to an NVH Simulator webinar before, but this information bears repeating. First, let's take a quick look at what NVH is. NVH is automotive sound and vibration. This includes powertrain sound and vibration, and you can see some of the typical phenomena here. Boom, shake, growl, tonal noises from gears and motors, and so forth. It also includes road noise and vibration, from secondary ride to imbalances and structure-borne and airborne road and tire noise. Wind noise is another major component. And then we have anything and everything else on the vehicle that makes sound or vibrates. Brakes, HVAC, chimes and warning sounds, and so forth. All of this falls under NVH. I want to emphasize here that sound covers a large portion of these phenomena. But vibration is also key to many of these, and there's a big overlap area here. Vibration is inextricably connected to the perception of sound in the vehicle, and vice versa, especially below 100 Hertz. Sound and vibration levels interact and affect the human perception of sound and vibration in ways that are not always intuitive. To accurately assess sound or vibration at lower frequencies, it is vital that the correct levels of vibration are delivered to all driver touch points independently, together with sound. When assessing conditions like road impacts, idle, lugging boom, and other such phenomena, vibration and sound need to be presented together for the correct assessment to be made. What we'll be covering today addresses how we engineer the right sound and vibration characteristics into the vehicle. NVH is one of the main attributes controlling and delivering vehicle refinement and brand DNA. Comfort, quality, and character are all communicated to the driver, passengers, and observers through the sound and vibration of the vehicle. Sound and vibration are intrinsic parts of the driving experience. Consciously or not, people make decisions and form opinions based on the sound and vibration they perceive from the vehicle. Buying decision, perception of quality, reliability and proper function, and emotional response, whether positive or negative, are all considerably influenced by the sound and vibration of the vehicle. NVH embraces a number of factors essential to delivering the overall driving experience and communicating brand DNA. Many types of engineering data and CAE analysis can be adequately expressed, experienced, and understood visually. Decisions can be made by looking at a computer monitor. NVH data is a bit different. We get a lot of great information from testing, analysis, and simulation, but the results are typically in the form of plots and graphs. NVH data cannot be fully expressed, experienced, and understood by plots, graphs, numbers, and visual means. Numbers, plots, and graphs are very useful, but they don't answer questions like, does it sound good? Or is it better than this other car? Or my favorite, what does it sound like? Or how does it feel? To address this, we created our NVH driving simulators to enable the experience of all the various types of sound and vibration data together in an interactive, real-time driving simulator. We're going to show a short video now. In this example, you will see the desktop NVH simulator, which of course encompasses only the experience of sound. With the NVH simulator, you have full control over the vehicle. Drive just as you would drive a real car with accelerator and brake pedal, steering, gear shift. Change sounds back to back on the fly while driving. You can also turn components on or off, or modify component sounds with filters, or adjust their levels, or swap components, all while running the real-time simulation. All right. So the NVH simulator came from a desire to experience and therefore to understand fully what the NVH data we had meant to customers in their cars. And really behind this was the need to make better NVH decisions about design alternatives and content faster and with higher confidence. That meant adding interactivity and context to the traditional sound quality listening experience. Adding interactivity meant creating an NVH virtual prototype vehicle made up from traditional types of NVH data, which could be driven in a simulated environment. The ability to experience NVH data using highly accurate sound and vibration synthesis in a real-time driver-in-the-loop situation, including the ability to modify parts of it in real time, enables design for the customer in the field of NVH. It can be quite useful to simulate existing vehicles for benchmark studies or the like, but the real value of the NVH simulator comes when it is applied to data for vehicles which do not exist yet. The NVH simulator is extremely flexible in incorporating data from many CAE tools, test techniques, and taking NVH data from almost anywhere to allow engineers to experience and assess the best representation of the new vehicle at that time. The NVH simulator technology has been developed with the benefit of Brüel & Kjær's long legacy of sound and vibration innovation. So we've just seen the desktop NVH simulator in action, and there are more than 50 desktop NVH simulators installed at customer sites worldwide. The desktop NVH simulator is the basic workstation. This is where all the models are compiled, and the desktop version provides sufficient context for many types of evaluations. The virtual vehicle models can be driven interactively with pedals, gear shift, and so forth. The models are fully interactive with complete control over the sound. You can switch instantly back to back, turn things on and off, turn off and on component parts of the sound like wind noise, road noise, powertrain, modify parts of the sound in real time with multiple types of filtering and sound modification tools. The NVH Simulator software is at the core of all these solutions and is used in all versions of the NVH Simulator. For many years, we've offered the static NVH Simulator, sometimes referred to as the full vehicle NVH Simulator. Several of these have been built and delivered to customers and are in use today. The static NVH Simulator adds calibrated, multi-axial, independent vibration at all driver touch points. Built into the shell of a complete vehicle with expansive visuals, it provides the evaluator with the full context of being in a real car. In the static NVH Simulator, the evaluator can fully experience realistic, calibrated vibration and sound in an immersive environment. This is one of the best ways to experience NVH data. The static NVH Simulator does require a bit of space, considering an entire vehicle is used as a starting point. It generally requires a dedicated room, and quite a bit of work is done to customize the vehicle, the vibration system, and the overall system as a whole. So we started thinking, what if we could provide the same vibration and sound capability in a smaller footprint, one that could easily be accommodated in the engineering office, right where the engineers are working and developing the next vehicles? And what if we could do this at a significantly lower cost? I would like to introduce to you the new Compact NVH Simulator. The Compact NVH Simulator was officially launched at the SAE Noise and Vibration Conference and Exhibition held in Grand Rapids, Michigan earlier this month. There, the Compact NVH Simulator was on the show floor, available to be driven for the first time. Many of the NVH experts at the show got a chance to experience this new NVH Simulator firsthand. While at the show, we shot some video footage and created the all-new Compact NVH Simulator Introduction video. I hope you enjoy it.
Hello and welcome. I'm Dave Bogema, Director of NVH Solutions at VI-Grade, and today we're here to announce the latest in our family of NVH Simulator solutions. Across the automotive industry, the prevailing trend is to reduce physical prototypes and focus on upfront design, relying on simulation and virtual prototypes. And while tremendous strides have been made in the ability to simulate all aspects of new vehicle designs, NVH is one of the attributes that really needs to be experienced. Numbers, plots, and graphs are all extremely useful, but to really understand sound and vibration, it needs to be experienced. For many years, the desktop NVH simulator has been providing NVH engineers with the ability to drive, experience, and understand sound and vibration phenomena using virtual NVH prototypes, and to communicate NVH issues and design concepts to decision makers. We have also constructed several static or full vehicle NVH simulators, which incorporate vibration as well as sound. These static simulators are extremely useful in experiencing, understanding, and assessing vehicle vibration and sound. But the static simulators typically utilize a full-size vehicle as a starting point, and consequently take up a fairly large amount of space and require a dedicated room. What we wanted to do was to create a simulator with the same vibration capabilities as a static NVH simulator, but to create this with the smallest possible footprint so that it could be used in the engineering office, and also relocated relatively easily. The Compact NVH simulator enables the accurate experience of vibrations at all driver touchpoints, together with sound, in a small footprint that is compact and portable. Accurate, calibrated, multi-axial vibration is provided at the seat, steering wheel, and floor pan. Each axis of vibration can be independently controlled, and each axis is independent from all others without crosstalk. So when the steering wheel vibrates, it does so completely independent from the seat. The seat does not vibrate due to the inputs to the steering system, or vice versa. This provides engineers with the ability to understand the trade-offs between vibration levels at different driver touchpoints, as well as sound levels. It also enables driver-in-the-loop free driving of NVH virtual prototypes. You can see that carbon fiber is used extensively in the construction of the compact NVH simulator. The entire frame and even the steering wheel are composed of carbon fiber. This makes an incredibly stiff structure suitable for delivering controlled, accurate vibration to the evaluator. No modes of vibration of the frame or steering wheel significantly affect the vibration response, enabling accurate vibration and experience. Several electrodynamic shakers are used in the design to provide the capability for high levels of vibration across a wide frequency range. The shaker on the back of the seat is quite obvious, and if you look closely, you can see some of the other ones under the seat and around the steering column. There is a built-in touchscreen interface to enable drivers to easily control the simulator and provide feedback on vehicles and virtual prototypes they experience. The dash screen is provided for easy feedback to the driver for vehicle speed, RPM, gear, and other parameters. This dash screen is customizable and will evolve with the needs of NVH simulator users. Sound is provided through calibrated headphones connected to a headphone port on the console, along with a subwoofer for low frequency accuracy. We have two options for screens. The one we have set up today is a large flat panel display which enables a very small overall footprint. A large curved screen and projector is also available to provide a more immersive visual experience. Over here, we have the compact NVH simulator rack, which houses all the amplifiers and other equipment necessary to power the compact simulator. And we have the control desk, where the operator will set up, control, and monitor the simulations as the evaluators drive the simulator. The NVH Simulator software is used in common across the desktop, compact, and static NVH simulators. The compact NVH simulator is ideal for providing realistic evaluations of road noise and vibration on various surfaces, and also for road impacts. It is also vital for evaluating powertrain issues like cylinder deactivation, engine start-stop, lugging, idle boom, and many others. The compact NVH simulator enables better decisions to be made faster with confidence during the design and development of vehicles by providing automakers and suppliers with the ideal way to experience, understand, and decide on the sound and vibration characteristics of the vehicles long before physical prototypes could be available.
All right, so there you have it, the new compact NVH simulator. The compact NVH simulator is the first simulator of its kind in the automotive industry. I thought I'd take a few moments and go over some of the key features of this new simulator in more detail. The key focus of this simulator is calibrated, integrated vibration and sound, delivered in a system which can simulate any vehicle regardless of its own inherent vibration characteristics and dynamic behavior. 7 independent degrees of freedom of vibration are delivered to the driver. Vibration is delivered to the seat in the vertical, lateral, and fore-aft direction. The steering wheel has vertical and lateral vibration components, and the footwell or heel point has vertical and lateral vibration as well. This combination delivers vibration to all driver touch points in the vehicle, providing a very realistic and accurate experience. Of course, the vibration is calibrated and equalized so the exact vibration stimulus which simulates the vehicle is delivered to the driver. Sound is also a critical piece of the evaluation experience, so highly accurate calibrated sound is provided through high-quality headphones and a subwoofer. It is really the combination of sound and vibration that delivers the unparalleled NVH experience. The driver can interact with the simulator and the virtual prototype vehicle models using the controls and displays in the simulator. This includes the pedals, a steering wheel, a large dash screen for vehicle speed and other information, multiple ways to shift gear in the vehicle with paddle shifters and a gear stick that can be switched from sequential mode to H pattern, and finally, the touchscreen. The touchscreen enables not only the selection of vehicle models, but also as a way for the driver to provide feedback on the vehicles he is driving. It can also be used to modify and control the sound and vibration levels. It is worth noting that the brake pedal uses an actual hydraulic automotive system, including a physical brake cylinder and caliper, to provide extremely realistic brake feel. The steering motor used in the compact NVH simulator is the same professional steering motor used in all VI grade driving simulators. This means that realistic steering feel and feedback is part of the overall driving experience. In the video, you saw primarily the flat panel display in use with a compact simulator. The standard display screen is a large curved screen with a projector mounted behind the driver. This provides a wide field of view, very high quality graphics, and an immersive driving environment. While still providing high quality visuals, the flat panel display is useful when the smallest possible footprint is required. The compact NVH simulator utilizes carbon fiber extensively in its construction. The goal was to design a frame with high stiffness that would provide accurate vibration in a relatively lightweight system that would be fairly easy to move. The frame has been designed using simulation and finite element modeling, of course, to be extremely stiff and provide a very stable base for the steering system and steering vibration module. With this structure, it is possible to deliver well-controlled and accurate steering wheel vibration. The steering wheel itself is made out of carbon fiber and is very light and rigid, with no rim modes below 200 Hz. The steering wheel is covered with a thin layer of Alcantara material to provide the realistic feel of an automotive steering wheel, while still transmitting controlled and accurate levels of vibration. In this picture, you can also see the steering motor over here on the left, which I mentioned a minute ago. This is a professional grade steering motor used in all of our driving simulators to provide realistic steering feel and feedback. At the heart of the compact NVH simulator is the NVH Simulator Software. This software is used in common with all versions of the NVH simulator, from the desktop to the compact and the static, and even the on-road simulator and exterior sound simulator. Any models prepared for use with a compact NVH simulator can be directly utilized on the static NVH simulator with no further modification. These can equally be used on the desktop NVH simulator, but without the vibration experience, of course. The key point is that the same software and data models used on the desktop NVH simulator can be used for the compact, static, and other versions of the NVH simulator. The NVH Simulator software has been expanded and updated with many new capabilities for supporting multi-channel vibration output and monitoring, and for easy data management of multi-channel vibration and sound data. So, what is the compact NVH simulator used for? Well, really anything where vibration is important. Going back to our first slide, there are multiple arenas of NVH where vibration is key. For traditional hybrid powertrains, we have conditions like idle, lugging, cylinder deactivation, engine start-stop events, and many others. But electric vehicles are not free from vibration. In addition to road-induced vibration that may seem more prominent in the absence of powertrain sound and vibration, other accessories can generate vibration. For example, AC compressors. What level of vibration on the steering wheel is acceptable when parked at a stoplight in an EV with the air conditioning running? In general, there are many road-induced vibration and sound conditions. Rough road, impacts of various types, transitions from rough to smooth road, various road surfaces, and so forth. It's also important to note that in addition to specific vibration phenomena that may be important, simply having vibration of the road and powertrain adds a great deal of realism to the experience of NVH data. At the SAE NVH conference a couple of weeks ago, I had a number of engineers who've been evaluating vehicle sounds for many years drive the compact NVH simulator and tell me that it was like adding a new dimension to the NVH experience, that the new aspect of experiencing vibration along with the sound they were used to hearing made the whole experience much more immersive and much more real. To highlight one use case, impact harshness can be evaluated using the NVH compact simulator. Impact harshness in particular requires high amplitudes and correct, accurate magnitude and phase in each direction of the seat, steering wheel, and floor pan. Here you can see some visual displays that are used in one of our demos. Both two-wheel and one-wheel impact test scenarios are shown here. Let's take a step back for a moment. For all disciplines and attributes, the traditional approach to designing a new vehicle has been to dream it, to get an idea, then to make it or build a prototype, and then drive it, see how it works. A much more efficient approach is to try it before you build it. Eliminate the wasted time and cost of building multiple prototype iterations. Simulate and experience the results of the simulation in driving simulators first. Iterate much faster than before possible with traditional approaches. This is the faster, easier, and safer approach to developing vehicles. I'd like to revisit some of the basic concepts and capabilities of the NVH simulator, which apply equally to sound and vibration data, and to the desktop, as well as the compact, static, and other versions of the NVH simulator. The NVH simulator can bring together data from multiple sources into a single, unified virtual prototype. This can include vehicle measurements, component rig measurements, CAE data of many types, and all of these can be combined into a single model. These virtual prototypes can then be used to communicate NVH information to decision makers and those who need to know. They can show stakeholders and colleagues why their input matters. One of the questions I'm asked a lot is, how much data do I need to make an NVH simulator model? Especially with multi-channel vibration data, it might appear that creating models could be quite involved. Well, the good news is that it doesn't need to be difficult. It all depends on what the model will be used for, how much accuracy, and how much detail is required. Simple level 1 models are very useful for benchmarking and high-level target setting and require very little time and data to create. Of course, you need some accelerometers and microphones, but the overall data collection is very simple and does not take much time. Models can be more complex, moving to a level 2 model where the sound is broken into specific sources, especially for separating structure-borne road noise, airborne road noise, and wind noise. And moving to a further level of complexity, level 3 models accommodate the need to predict and understand what impact specific components will have on the overall vehicle sound and vibration. Source path contribution concepts are intrinsic to the NVH simulator and the NVH virtual prototypes. Source path contribution modeling is used to build up vehicle models from the component source level sound or vibration through the sound and vibration paths to the resultant contributions at the receiver or driver location. And models can exist anywhere in between here, matching complexity and capability to the need of the model. And again, any of this data can be real data measured on a test track or measured on a test rig, or come from many different types of CAE methods. While NVH simulator models can be created entirely from measured data or entirely from CAE data, the vast majority of NVH simulator models and virtual prototypes are hybrid models, a combination of CAE data and measured test data. Often, test data will be used to provide context for components outside the scope of the immediate evaluation task, or for data and frequency ranges that are outside the scope of immediate evaluation and analysis. For example, say road noise and vibration are being analyzed. A detailed finite element model of the vehicle and a high quality tire model are used to generate road noise and vibration levels for the vehicle, but only up to about 200 Hertz. This data can be accurately generated and played back in the NVH simulator, but listening to sound data up to 200 Hertz with nothing else above that is not so realistic. A good solution is to use surrogate road and wind data from a similar vehicle, perhaps even modified slightly to match future vehicle intent, and apply this sound above 200 Hertz while using the detailed analysis results for sound and vibration below 200 Hertz. As another example, perhaps we have powertrain vibration data generated from a CAE model, but we need some road vibration for context. We can use measured road sound and vibration together with the CAE generated analytical data to provide a complete, realistic scenario for evaluating the powertrain vibration data. CAE results and data are vital components of NVH virtual prototypes. We have worked together with several CAE suppliers to make it easy to bring CAE results into the NVH simulator and use these in virtual NVH prototypes. In fact, the NVH simulator is capable of easily accepting data from many different sources and in many different formats. Time data, frequency spectra, frequency response functions, and other data are easily utilized in the NVH simulator. The NVH simulator accepts measurements and data from a wide variety of sources in all common file formats. Some data can be directly used in the simulator with no further need of data processing, but other data needs some preparation to be used in a real-time simulation. For example, test-based time data typically needs to be decomposed into its component parts. During runtime, the data is not then simply played back, but it is actually resynthesized in real time in response to driver inputs. This measurement data is decomposed using incredibly precise and fast time domain order extraction techniques to separate orders from masking. Data can be further processed to separate the masking noise into its component parts. When needed, the best-in-class time domain source path contribution software can be employed to calculate acoustic source strengths and mount forces and prepare complex source path contribution or transfer path analysis data for efficient modeling and playback in the NVH simulator. Experience over the 20+ years of development and use and thousands of model builds have resulted in a set of tools which can handle virtually any data set and measurement situation when building NVH simulator models. As mentioned previously, the software used for the compact NVH simulator is the same that is used for the desktop NVH simulator, all functionality that is available for the sound is also available for vibration. For the compact and static simulators, it is simply a case of having more channels. The engineering interface, or mixer, provides complete control over the NVH simulator model or virtual prototype. Turn sound or vibration components or channels on and off, apply many types of modifications and filters, compare sound and vibration models back to back, visualize the sound and vibration in real time together with listening and feeling the actual levels. When applying filters, unlike in a sound quality program where filters are applied to the entire sound, here filters are applied to specific portions of the sound or vibration. So applying a notch filter to remove tire cavity noise from the rear tires, for example, is only applied to the rear tires, not to the engine noise, not to other road noise contributions, not to the wind noise. It is analogous to making an engineering change with a physical vehicle, like changing the tires. It should be noted that the model size and the number of filters and modifications are essentially unlimited. Huge numbers of filters and extremely complex models are easily accommodated. When working with sound and vibration data, sound and vibration objects can be grouped together so that you have a single entity or group that represents a physical part of the vehicle, which contains all sound and vibration outputs related to that component. As with other VI-grade solutions, the NVH simulator solutions have been designed from the beginning to be open and capable of interfacing to a wide variety of other software. External performance models from Simulink or other external real-time performance models, active sound design software, and other real-time software can be utilized in the loop side by side with the NVH simulator to achieve the high fidelity NVH virtual prototype experience you need, leveraging the existing solutions you are already using. There are numerous protocols and methods supported for integrating the NVH simulator software together with other real-time software solutions. Similarly, hardware can be incorporated in the real-time simulator with the NVH simulator solutions. The NVH simulator software can interface with a wide variety of hardware through multiple methods. And now, the NVH simulator software is compatible with all other VI-grade solutions, including VI Car Real-Time for vehicle dynamics, VI Graph Sim, VI Drive Sim, and VI World Sim. Any or all of these can be used in combination with the NVH simulator software and the compact NVH simulator. If you were at the NVH conference a couple of weeks ago, you probably saw the NVH simulator operating with the road visuals from VI World Sim. And that brings us to the end of this presentation. In summary, the new compact NVH simulator is the first simulator of its kind to provide accurate, calibrated, multi-axial vibration together with sound for a complete NVH experience in a convenient size and cost-effective price. It further enables the ability to accelerate product development from concept to sign-off by bridging the gap between testing and simulation, getting you to virtual sign-off faster. Drive, experience, understand, and decide. The new compact NVH simulator enables you to experience the vibration and sound of your virtual prototypes, understand and communicate NVH information, and make decisions faster and with more confidence than ever before possible. Of course, it's quite difficult to convey the real value and impact of this new vibration simulator through a webinar. The best way is to try it out for yourself. I would like to invite you to plan a visit to one of our sim centers to experience the VI-grade simulators and solutions firsthand. Contact your local VI-grade representative to schedule a visit or learn more about VI-grade solutions. You can also visit vigrade.com for more information on any of our solutions. All right, so thank you very much. I believe now it's time for our Q&A session.
Yes, Dave, thank you very much for the interesting presentations, as well as to all attendees. So we are now ready for the Q&A session. I believe that you have some pre-submitted questions, Dave, that you want to share with the audience, and I will share the other ones later on.
Great. Yeah, so we do have a couple of questions that have come in so far. So this is a good one. Can we put our own steering wheel on the simulator? Well, I can understand why somebody might want to do that, but what we've done is we've actually created a steering wheel that is extremely stiff and delivers exactly the vibration we need to. It's completely made out of carbon fiber. One of the things that, so we had tried previously using just a regular automotive steering wheel, and most automotive steering wheels are actually quite compliant. And what would happen is we would shake it in the vertical direction, and we would get all sorts of vibration in other directions that we didn't want, especially the fore-aft direction. And that's just because of the modes of the steering wheel, the rim modes, and so forth. So it was very difficult to deliver calibrated, accurate vibration using a typical automotive steering wheel. So we developed this new steering wheel. It's extremely stiff. In terms of the rim modes that were giving us trouble before, there's no rim modes below 200 hertz. So essentially that steering wheel can emulate the feel and the dynamic response of any car, any steering wheel. So that's why we're using that particular steering wheel, and why it wouldn't really make a lot of sense to try to put a customized steering wheel or take one off a car and just stick it on there, because you can't get the same vibration response that way. All right. Good. So another question here: can different seats be placed onto the compact NVH simulator? Again, I can understand why somebody might want to do that, but in reality, what we've done is we've designed a seat that is very special, and it basically will emulate any seat that you want to. So instead of bolting different seats down to a motion platform or something, we've got a seat that's been highly modified that can then represent any seat. And that actually opens it up so you can simulate seats, before they're actually even prototyped. Another aspect of that is the way we've designed this seat. And again, something we've learned from developing these things in the past. If you try to shake the entire seat structure and the person and everything, it's a lot of mass, and you run out of force very quickly out of your shakers. So what we're doing is we're moving the smallest amount of mass possible. We're actually shaking the person himself and not the overall seat. And again, what that does is it enables us to achieve higher vibration levels with these electrodynamic shakers. So it keeps the system simple and low cost. It also helps us separate those degrees of freedom, the vertical and lateral and fore-aft degrees of freedom. So yeah, it's very similar to having a pair of headphones that you put on your head. You don't have to create a new vehicle cabin every time you're assessing a new vehicle, so you get the cabin acoustics right. You just put on a set of headphones. Same thing with the seat, and really for the steering wheel too, that we just talked about. The seat and the steering wheel can really emulate any seat or steering wheel that exists, and that's why we created them in that way. And let's see, we've got another one here. Well, that's a good question. Where can I get a demo of the compact NVH simulator? So the compact NVH simulator right now today is sitting in our Detroit office in Canton, Michigan. So if you're in the U.S. in the Detroit area, it's here. Come on over. In the UK, we've got our full vehicle simulator in our sim center there, which has the same vibration system. So you'll get the same vibration and sound experience there. And then it's also possible in our Udine, Italy office to see this and get a demo. All right, that looks like all the questions I have here, Gabriele. Do you have any more that have come in?
Yes, I do. So the first one is related to the electrodynamic shakers. So the question is whether the system features electrodynamic shakers in all 7 degrees of freedom individually.
Yes, exactly. Yeah, we use electrodynamic shakers, and each degree of freedom has its own shaker, or in some case, multiple shakers in 1 degree of freedom. So yeah, so there's actually 12 separate shakers in the NVH Compact Simulator, enabling each direction to be excited independently. So if you want to put in only seat vertical, you can do that. Or if you only want steering wheel vertical, or if you say, well, what if I only use vertical vibration at all 3 points, you know, seat, steering, and floor pan, you can do that. Or yeah, they're all completely independent of one another.
All right, second question is if it's possible to mount the compact NVH simulator on top of a motion platform. That's a very interesting one.
Yeah, well, I'm very interested in that too. We have not done that yet, but that is something that we are very interested in doing and exploring. As you can probably guess from what we've been showing here and in some of our other webinars, you know, where we really want to get to is a complete holistic simulation of vehicle dynamics and NVH on the same simulator that's completely calibrated and accurate and realistic. And so this is definitely a step in the right direction. And yeah, I would be really excited when we get a chance to try that out.
Another question is if it's possible to play simulation results of an own, essentially of a customer specific NVH model on the compact NVH simulator.
Yeah, I'm guessing that that's kind of in the sense of like a demo or something like that. Absolutely. You know, we can take data and put that onto the compact NVH simulator and play that. Yeah, from any vehicle. We just have to have the right data to do that with. So that would be easily accommodated.
Okay, going forward. Can the simulator provide response also for dynamic missions, like lateral response?
Sorry, I lost the last couple words there.
The question is whether the simulator can provide responses also for dynamic missions. For example, lateral response, lat response.
Oh, lateral response. Mm-hmm. Yeah. So in the lateral direction, or really all the directions, you know, the core frequency range that we're shooting for is about 10 to 100 hertz, and that's super conservative. You can easily go down to 6 hertz or possibly even lower using that in any of the directions. It's really a matter of how much amplitude you need in those directions at the various frequencies. But the intention was to be able to simulate primary, or sorry, not primary ride, but secondary ride on up in terms of vibration. So you know, again, there's a really wide frequency range there, and pretty high amplitude capability. And yeah, we can definitely simulate lateral as well as the other directions.
So now there is a question on modularity of the simulator. So they're asking if it's possible to connect basically the simulator hardware with a custom specific NVH software solution.
I guess I would have to clarify what is meant by that. You know, we've really designed it in terms of the software and the hardware to, you know, for the NVH Simulator software to work with the NVH Simulator, the compact NVH Simulator. But the NVH Simulator software can connect to lots and lots of different solutions for many different purposes. So it can run in real time and in parallel with lots of other solutions. So I guess I would just need a little bit more clarity in terms of what exactly was being requested there. But that's something we can follow up on after the webinar.
So there is a generic question, or essentially a couple of questions that converge into a similar one that is related to the vehicle model that is used on the compact NVH simulator. So the question is, besides FIF models, time frequency data, if there are other types of models that can be used, for example, maybe a multi-body model coming from atoms or reduced AVA models. So in a wider sense, what are our plans to support a wider way of representing vehicle models, basically?
Well, you know, we support quite a few different types of data coming from different places. You know, we've certainly, you know, in terms of CA analysis, you know, data from FE models is real common. Data from multi-body models from atoms and other places is really common to support. You know, higher frequency data from something like, you know, for example, Actran, or you know, we just, as a matter of fact, just a couple of weeks ago, we did a WebEx together with Romax, in how we utilize data. They actually output data directly in the right format for the NVH simulator to use for simulations from their software. Lots of different types of simulation software that we can accept and use together with the NVH simulator.
Okay, maybe another, we have time for another two, I guess. One would be, this is kind of an interesting question. If the simulators have been used or could be used in the off-highway market, for example, outdoor power equipment or construction equipment.
Yeah, absolutely. It's certainly not limited to just cars. Anything where, you know, you need seat and steering wheel type vibration for vibration and sound. In fact, you know, for the desktop simulator, we've used it with motorcycles and power boats and other types of vehicles, tractors, you know, heavy trucks, Class 8 trucks. You know, that it's quite versatile and applicable to those types of products.
Okay. I can't see any more questions, and we are also getting close to the end of the allocated time. So I would like, first of all, to thank all attendees as well as our presenter, Dave Bogema, for the interesting presentation. At this point, our webinar dedicated to the argument enabling a complete noise, vibration, and harshness experience with the compact NVH simulator is coming to an end. Please remember that a recording of the session will be sent to you tomorrow per email. Please also take your time to participate in our survey that will be displayed when leaving the webinar. Please also feel free to download our driving simulator brochure and Sim Center brochure that you will find in the webinar control panel. The brochures feature a detailed overview of VI Grade's driving simulators product line, as well as Sim Centers allocated around the world. If you're interested in learning more about our NVH solutions, or you wish to book a visit to the Sim Center near you, we invite you to visit our website, vigrade.com/NVH. Thank you again for attending, and see you soon.